This video is Fourier expansion of f of x in -2 to 2. Hey friends, so now we are gonna solve another example on Fourier series. So here we have to find out the Fourier expansion of f of x, which is equal to 2 when x is between -2 to 0 and f of x is x when x is between 0 to 2. Now guys, if you observe this question carefully and if you check the range, then it is from -2 to 2. So it means here we have to find out the Fourier expansion of f of x in the range -2 to 2, or it is matching with the type -L to L. So in this interval, to get the Fourier series, we have a formula. So here I'll say, here the value of L is equal to 2, and we'll write down the formula. So the Fourier series for f of x in -2 to 2 is given by. So guys, this formula we have already covered in the previous video, so I'll write down that formula directly. So it's f of x equal to a naught plus summation n equals to 1 to infinity an cos of n pi x by L, and guys here L is 2, so it is upon 2, plus summation n is from 1 to infinity bn sine of n pi x upon 2, and I'll call this as equation number 1. So guys, now we just have to find out the Fourier coefficient, that is a naught, an, bn, and we'll put it in equation 1 to get the Fourier expansion. So let's start. So to get a naught, we are going to use a formula which is 1 upon 2l, so that will become 1 by 4 integration from -L to L, so -2 to 2, f of x dx. Now guys, the range of integration, that is -2 to 2, is divided into two parts. One is -2 to 0 and other is 0 to 2. So I'll divide this range into two parts. So it becomes 1 by 4 first range, that is -2 to 0. Now in this range the value of f of x is 2. So I'll write here 2 dx plus in the second range, that is 0 to 2, the value of f of x is x, so that will become x dx. Now guys, here therefore we will get a naught equal to 1 upon 4. Now let's evaluate the integration. So integration of this 2, so 2 will come outside, we will get 1 here. So integration of 1 is x, so we will get 2 outside x, and the limit is from -2 to 0, plus the integration of x is x square upon 2, so here we will get x square upon 2 from 0 to 2. Now guys, let's put upper and lower limit. So 1 by 4 as it is 2. So here the upper limit is 0, I'll put 0, middle sign minus, lower limit is -2, so this will be -2, and minus minus plus 2, plus upper limit is 2, so this will be 2 square plus 2 square upon 2. It means 2 square is 4, 4 upon 2, we will get 2, minus lower limit is 0, we will get 0. Now let's solve this guys. Here we will get 1 by 4, 2 into 2, that is 4, plus 2, so which is 6. So we are getting 6 upon 4, or I'll say it is 3 by 2. So this is what the value of a naught. Let's find out an. So the formula for an is 1 upon L, as the value of L is 2, so 1 by 2 integration from -2 to 2, which is -L to L, f of x cos of n pi x by L, so that will become cos of n pi x upon 2, because here in this question value of L is 2. So this is 1 by 2 Now to evaluate this integration, this range minus 2 to 2 is divided into two parts. So minus 2 to 0 and 0 to 2. So I'll divide this range into two parts. So here we will get minus 2 to 0, which is first range, in which the value of f of x is 2. So 2 cos of n pi x by 2 dx, plus the second range is 0 to 2, in which the value of f of x is x. So x cos of n pi x upon 2 dx. Now guys, let's evaluate this integration. So 2 I can take it outside. So we will get half 2 outside. The integration of cos n pi x upon 2 will be sin n pi x upon 2 upon derivative of that. So here I'll write down, it is sin of n pi x upon 2 whole upon n pi by 2 from -2 to 0, plus. Now guys, if you see the second term, here we have two functions, that is x and cos n pi x by 2. So guys, here I am gonna use the rule of u into v. So we will call this x as u because it is algebraic function, and this cos will be v. Now by using the shortcut formula to find out the integration of uv, we will get first term as u, second term as v1, that is integration of this term. So here we will get first term as x, second term, that is integration of cos, that is negative sine of n pi x by 2. So guys, this will be positive because the integration of cos is positive sine upon n pi by 2. Next, middle sign minus u dash, the derivative of x, which is 1, then v2, that is integration of this. So integration of sine is negative cos of n pi x by 2 upon n pi by 2. So guys, here already we have n pi by 2 into n pi by 2 will become n square pi square by 4. Next, plus u double dash, that is derivative of 1 is 0, so I will not write that term, and here I will close the bracket. It is from 0 to 2. Now guys, we are just going to evaluate this. So let's substitute upper and lower limit. So half as it is. So here how I am doing it. So 2 here in the bracket, let's see what we get. So if I put x as 0, we will get sine 0, which is 0, middle sign minus. If I put -2 here, so 2 and 2 cancel, we will get sine n pi, and guys, sine n pi is also 0, so it means we are gonna get 0 from first term. Plus, now in the second function, I am gonna put upper limit as 2 and then lower limit as 0. So let's start. If I put upper limit as 2, we will get here 2 and 2 cancel because x is 2 and sine of n pi is 0, so again first term is 0. Then minus and minus is plus. If I put 2 here, 2 to cancel, cos of n pi is negative 1 raised to n upon n square pi square by 4, and guys, this 4 will come in the numerator, and here we will get 4 upon n square pi square. So this is what we got by substituting upper limit as 2. Minus, let's put lower limit, which is 0. So if I put 0 here, we will get 0 straightforward. Minus and minus is plus. Cos of 0 is gonna be 1 upon n square pi square upon 4. Now that 4 will come in the numerator, and that will become 1 into 4, that is 4. So guys, here half as it is. From these two terms, I can take 4 outside. I can take n square outside, I can take pi square outside. Now let's see what remains in bracket. So this is 0, here positive minus 1 to the power n, and this will be minus 1 because all these three terms we have taken it outside. Now here 2 ones are 2, 2 twos are 4, so we will get value as 2 upon n square pi square into minus 1 raised to n minus 1. So guys, this is the value of an. Now guys, let's find out the value of bn. So the formula for bn is exactly similar as of that an. The only difference is instead of cos we write sine. So I'll copy down this formula. So we will get bn as one by 2 Now guys, this range is divided into two parts, which is minus 2 to 0 and 0 to 2. So I'll divide it into two parts and I'll put the respective value of f of x in the integration. So we will get, now in this range the value of f of x is 2, and in this range the value of f of x is x. Now guys, let's evaluate the integration. So for the first term, I'll keep half outside, 2 will come outside, and the integration of sine is negative cos. So we will get minus cos of n pi x by 2 upon n pi by 2, and limit is from minus 2 to 0, plus here we have two functions, so I'm gonna use that u into v rule, where my algebraic function is gonna be u and the other function as v. So let's start. So here u as it is, then v1, that is integration of sine term, that is negative cos. So here I'll say it is minus cos of n pi x by 2 upon n pi by 2. Next, middle sign minus derivative of x, which is 1, and the integration of this term. So again minus n as it is, integration of cos is sine n pi x by 2 upon n pi by 2, but already we have one more n pi by 2, which will become n square pi square by 4. And guys, here I'll stop, because if I find out derivative of 1, I'll get 0. So it is 0 to 2. Now let's put upper and lower limit to get the value. So half as it is, so 2 as it is. Now here in this function, if I put x as 0, I'll get cos 0, which is 1, but since it is negative, we will get minus 1. So minus 1, and this 2 will come in the numerator, so we will get minus 2 upon n pi. So guys, this value I got by substituting the upper limit, which is 0. Now middle sign is minus, so let's put lower limit, which is minus 2. So here if I put minus 2, 2 and 2 cancel, we will get cos of negative n pi. Guys, we know that cos of minus theta is cos theta, so cos of minus n pi is cos n pi. So cos of n pi is minus 1 raised to n. But guys, with this we have negative sign also, and this 2 also. So 2 will come in the numerator, and here I'll write down that this minus and this middle minus will become plus. 2 will come in the numerator, here I'll write down that 2 upon n pi. So guys, I'll explain you one more time. So what we'll do is, to substitute the lower limit, I'll put minus 2 here, minus 2 and 2 cancel, so minus n pi. Cos of minus n pi is cos n pi by the property cos of minus theta as cos theta. Now value of cos n pi is minus 1 raised to n. Now still minus sign is remaining, 2 will come in the numerator which will become minus 2, but already the middle sign was negative, so negative, and this minus 2 will become positive 2 upon n pi. Next, this sign is plus. Now let's put upper limit which is 2. So this will be again 2 cancelled, cos n pi minus 1 raised to n, and here we have minus and x is 2, so minus 2 and minus 1 raised to n upon n pi by 2. Now guys, I'll write n pi here and I'll take that 2 again in the numerator, so that is gonna be minus 2 into 2 minus 4. I'll do it in next step. Next, if I put 2 here, I'll get 0 because 2 and 2 cancel, sin n pi is 0. So this is what I got by upper limit. Middle sign minus. Now let's put the lower limit which is 0. So if I put 0 here, we will get 0 into this 0, sin 0 0, so it means we will get 0. So guys, we got these many terms. Now let's expand these terms. So I'll multiply these two terms with 2. So we will get bn as 1 upon 2 in the bracket. This will be minus 4 upon n pi. This is 2 into 2, that is 4. So positive 4 minus 1 to the power n upon n pi. Next, here minus 2 into 2, that is minus 4 minus 1 raised to n. So here I'll write minus 4 minus 1 raised to n upon n pi. Now guys, here I'll cancel these two terms because they are same and opposite in sign, and here therefore bn will be 2 1s are 2, 2 2s are 4, so minus 2 upon n pi. So guys, we got the value of a naught, an and bn. So this is the value of bn. We got this as an, and now we are going to substitute all this value of a naught, an and bn in the equation number 1. So this is equation number 1. Here I'll put the value of a naught, an, bn. So here we'll say that from equation number 1, by substituting the value of a naught, an and bn, we will get f of x equal to so this is what the value of a naught. Now let's put value of an. So if you observe this an carefully, then 2 and pi square are constant, so I'll take it outside the summation. So here we will get 2 upon pi square outside. In summation, that is n equal to 1 to infinity, we will write the remaining terms, that is minus 1 to the power n minus 1 upon n square into cos of n pi x upon 2. Now let's put the value of bn. So guys, this is what the value of bn. Out of that, minus 2 and pi are constant, so we will take it outside. So here we'll say minus 2 by pi, summation n is from 1 to infinity. Only 1 by n will remain inside, so that will become 1 by n into sine of n pi x upon 2. And guys, here we get the Fourier series for a given function. So if you want, you can expand it by taking different values of n, or you can keep this value, this answer as it is. So I'm sure that you understood how I got the value of a naught, an and bn for the range minus 2 to 2. So guys, if you want to access all videos of Fourier series and engineering mathematics, then do visit to Ekeeda and find my videos at one place. Thank you very much.